Imagine walking through a primeval forest. Towering trees, air thick with the scent of damp earth, and silence. Suddenly, from a nearby bush, a dinosaur the size of a large dog bursts out. It's covered in strange, fuzzy feathers, and its eyes are sharp as daggers. You think you could outrun it or even fight it off? Maybe. But what if its bite, even a small one, carried a secret weapon? Something that made your blood refuse to clot, your body go numb, slowly dragging you into a painful death while the predator just calmly watches from a distance. Sounds like a monster movie plot, right? But this might have been real. For decades, the idea of a venomous dinosaur was dismissed as fantasy, a conspiracy theory, a tall tale, until scientists uncovered a bizarre fossil with teeth unlike any other. Teeth with delivery grooves. So, is this the ultimate proof of the most terrifying predator you've never heard of? Or is it all one massive scientific misunderstanding? We're about to step into a heated debate where every fossil clue is a piece of the puzzle. The venomous dinosaur, myth or living nightmare. Meet Sinornithosaurus, the Chinese bird lizard. The name alone tells you it's no giant. About the size of a big retriever, roughly 3 feet long, and covered in primitive fuzz-like feathers, it looked more like a weird bird than a classic monster. It belongs to the Dromaeosaurus family, relatives of Velociraptor and Utah raptor, the fast, smart predators with deadly sickle claws. But in 2009, a team led by Professor Enpu Gong studied Sinornithosaurus's skull and dropped a bombshell. They claimed they might have found the first evidence of a dinosaur that was venomous. What made them think that? Let's examine the criminal evidence preserved in stone for 125 million years. The case hinges on 3 strange features of Sinornithosaurus's skull, setting it apart from its dromaeosaurid cousins. First, and most importantly, the teeth. Its teeth were unlike any other predatory dinosaurs. While T-Rex teeth are thick, conical bone crushers, Sinornithosaurus's teeth were long, needle-like, and razor-sharp. But the key detail is the longitudinal grooves running down the back of each tooth. These grooves bear a striking resemblance to the venom delivery grooves found in modern venomous snakes and lizards like the Komodo dragon or rear-fanged snakes. In those animals, venom from a special gland flows along these grooves and into the wound. Second, the upper jaw structure. Above the upper teeth in the jawbone is an unusual area with small pits and channels. The researchers suggested this could have housed a venom gland. Ducts from this gland might have connected down to the tooth roots, supplying toxin to those grooves. This structure is surprisingly similar to the jaw anatomy of some venomous snakes. Third, space for a venom pouch. The skull appears to have a cavity alongside the upper teeth, which could have acted as a reservoir to hold venom before delivery, much like in some snakes. The combination of these 3 traits, grooved teeth, a potential gland pocket, and storage space, painted a compelling and frightening picture. So, if this hypothesis is correct, how did Sinornithosaurus hunt? Imagine you're a small prehistoric bird, a mouse-sized mammal, or even a baby dinosaur in a nest. A Sinornithosaurus, light and agile, stalks you from tree branches or underbrush. Instead of a high-speed charge using its sickle claw, which it still possessed, its tactic might have been more subtle. It would deliver a quick, precise bite, much like a snake. Those long, fragile teeth weren't for holding or tearing flesh. They were designed to puncture and withdraw. As those teeth sunk, venom, if present, would seep along the grooves into the wound. And here's the horrific part. This venom likely wasn't a fast-acting neurotoxic killer like cobra venom. Based on its living reptile relatives, it was probably a cocktail of anticoagulants and shock-inducing agents. It would prevent blood from clotting, causing the prey to bleed uncontrollably from seemingly minor puncture wounds. Simultaneously, it could induce paralysis, shock, a drop in blood pressure, and immense pain. Picture it. You're bitten, you jump and flee. At first, the wound seems minor, just a few small holes. But then, the pain spreads. You feel dizzy, weak. The wound keeps oozing blood inexplicably. You can't run fast anymore. And as you struggle and weaken, the predator, Sinornithosaurus, simply watches from a safe distance. It doesn't need to risk a fight. It just waits patiently until its prey collapses from blood loss and shock. Then it moves in to feed, facing no resistance. It's an energy-efficient hunt to the point of cruelty, relying on the prolonged suffering of its victim. Of course, an extraordinary claim requires extraordinary evidence. The venom hypothesis was immediately met with fierce opposition and debate. Other paleontologists argued that the venom grooves were just cracks from fossilization, or that they were normal structural features to keep the slender teeth from breaking. The pits in the jawbone, they said, could simply be muscle attachment points, not gland chambers.
They pointed out that unlike snake fangs, Sinornithosaurus's teeth weren't hollow, like syringes, only externally grooved. This would make venom delivery less efficient. Furthermore, no direct chemical evidence of venom has ever been found in the fossil. It's all inference from morphology. The debate is far from settled. It splits scientists into two camps. One believes they found the first feathered serpent of the dinosaur age. The other thinks it's a massive overinterpretation of normal features. But even if Sinornithosaurus wasn't venomous, the idea opened a new door. It forces the question, why not? If later reptiles and mammals independently evolved venom multiple times, why couldn't the dinosaurs, who ruled the planet for over 100 million years, have experimented with it too? Interestingly, Sinornithosaurus isn't the only candidate. Another small dinosaur from South America, Ornitholestes, also had needle-like teeth that sparked speculation. Even Archaeopteryx, the first bird, was once briefly suggested to be venomous in an old study, though that idea has been largely dismissed. Even if the venom theory is ultimately rejected, Sinornithosaurus remains a fascinating creature. It shows the incredible diversity of hunting strategies among dinosaurs. Not all of them were giant flesh-rending machines. Some were small, specialized, sophisticated hunters who may have experimented with chemical warfare. It forces us to reimagine the entire Cretaceous ecosystem, not just as a stage for clashing giants, but as a world teeming with small, bizarre, and possibly even more insidious threats. And this is just one piece of the vast, unfinished puzzle of the dinosaur world. Every fossil, every scientific debate opens a new door to a past still full of unsolved mysteries, predators with impossible weapons, bizarre survival tactics, and stories stranger than fiction. So, what do you think? Was Sinornithosaurus truly the feathered serpent of the Cretaceous, or is it all just a strange fossil coincidence? Let me know your verdict in the comments below. If you don't want to miss any discovery on this journey to unearth the most terrifying and wondrous secrets of our prehistoric planet, hit subscribe and the notification bell right now. Let's keep peeling back the layers of history together in the videos to come.